Hi, and welcome to this video about vector store deltas. So I have made a bunch of videos already about how you get started with RAG and RAG in general. But there is the thing about when you ingest data into RAG, and if you don't know what ingestion means, if you don't know what RAG is, then definitely go see my other videos before you go into this one. Because this one is about what do you do day to day when your various data that needs to go into a vector store changes? There might be new additions, there might be changes, there might be deletions, and so on. And how do you actually take that into account? So I'm going to show various different methods, and they are all based on my experience throughout me making vector stores, from making them incorrect to assuming it was correct to actually finding real data ways of doing things. So what we're going to do is we're going to walk through this code. Here in the beginning, we'll just quickly have a small summary of how vector stores work. But again, we're not going to go into details in any way. See the other videos. And then we're going to try and use various different data as they evolve over time. So let's get into it. We just grab sequence like normal, and then we're going to do a little special in that we are on our Azure OpenAI client that we are going to use for embeddings. We are attaching a handler so we can actually see when something is being called, so we can check that there's actually been made a call up onto the online service where we essentially pay money for that. We're not going to write out exactly what was sent back and forward because that's just what we saw in some of the other videos, but just so we know that there's actually a call. But else, it's an entire normal client, and we are going to make a normal embedding generator. Then we are going to make a vector store. In this case, we're doing in-memory vector stores, but had we done it with any of the others, it would have been exactly the same code. Then we're going to make a collection. It's called knowledge space. And now comes the interesting part. Let me loop it down to here. We are going to import 3 vector records. And it's my normal knowledge base sample data here, but only 3 of them. And I've given them an external ID, which haven't been there in the past. So this is just a normal question, answer an external ID record. And what I'm simulating here is that, let's say this was day 1 of our vector store. Day 2, there has come a new addition. And day 3, someone changed one of the knowledge base entries. So we also need to reflect that in the vector store, else it of course can't know. Someone deleted one of the records, and someone added one more. So essentially just data being manipulated in other systems and need to be synchronized to the vector store so it's still up to date. And then I have various different ways of running a vector store. I have an incorrect way. This was actually the first one I did and didn't realize. Then there's an external ID as ID method, an efficient one, and a delta one, and a delta one with record reuse. We're going to go through all of them. The first one here will go into much details, and then we'll slowly go less and less details because most of it will be the same with all the different methods, and we're going to go into the differences between them. So what I'm going to do is I'm going to run a stopwatch, and this first time we run a stopwatch, it will definitely be too high, of course, because we are going breakthroughs here. Of these breakpoints. So the first one is our ingestion method, which is the incorrect way of doing things. So we're going to go into that in a switch. So I have an ingestion method here that takes the data. And what we're about to do, we're about to put in V1 of the data. And in here, we're going to do it the incorrect way. This first time, technically not incorrect, because what we're going to do is we're going to ensure that the database exists, or the collection of the vector store exists. And then we're going to loop through each one of them. And then normally just do obsert with a new grid for ID, external question and answer, just like we did in all the other videos. And when we do that, we can see there's a call to the online service, one more call, and so on and so forth. And once we're done, the embedding is complete, and we're gonna go in and list the store. And this is something we actually haven't looked at yet. How do you get all the records out of a vector store? So it is just as easily as insert, we have a get async. So we ensure that the collection even exists, and then we're gonna make a wait for each here where we say get async. And get async will normally take a filter, meaning let's get all the records that have this value in a category or something like that. So this is just a lambda, but in my case, I just want everything. So I'm just saying records lambda true, meaning all records. And I'm saying how many do you want? I want all of them, so I just take int.max value. And in my retrieval options, I'm saying I don't want the vector, because I don't really care about the vector in this scenario. I only want the raw data that we are actually putting in as metadata. And as a reminder, that's an ID, a question, an external ID, an answer, and the vector we don't care about. I have something called lookup key here. We will see what that is about in 1 second. But what I can essentially do here is I can loop through every single record and put them in an all records collection, meaning I'm just getting out all the three we had from the first import. And then I'm just gonna write those out. It says that the first one was V1. We needed to import 3 records. And as expected, there are 3 records in the vector store. So I'm just gonna go up here and set some breakpoints here, so we can see that we get our 3 data out here. We get our 3 entries, their question, their answer, and their ID. And the IDs are just grids, because that was what we asked in the incorrect version here. So our import is correct. People can use the vector store for vector searches in AI and like always. But now comes day 2. And again, day 2, we add 1 more record. So we do exactly the same. We just loop through our data and observe it. And this will go wrong, because now I'll just let it run again. Because there was 4 records, we called the vector store 4 times, and the embedding is complete. But what we are gonna see is that we actually have 7 records in the database. And why do we have 7 records? That's because we're just giving new IDs. Every single time we do an obsert, we are actually just giving a brand new ID. So the same thing will be here twice. And it will go even further wrong. Let me begin to have this in full screen while we run it. At the end, we will essentially end up with 11 records, same record multiple times, just with different IDs. This was my first attempt back in 2024 when I made my first vector store. I had not understood it correctly, and I ended up with things like this. Just so we can see, oh, let's wait with the times so far. That's not too important. So that was incorrect version. Of course, you shouldn't do that, But just so you understand that when you ingest and you say upsert with an ID, of course it will get a random ID and begin to run. So now you might think, okay, I have an external ID. So I can fix this. I can just, when we run this again, and let's jump into the ingestion. And now we're going into a different ingestion. And the only difference is that the ID is not just a GUID anymore, but now the external ID. So each of these records have an ID 1, 2, 3. When the new record comes along here, it's 4. And a new record comes along here, which is 5. So we might think, okay, now we're safe. So let's run this to the end and actually see the result. And as we see, it looks correct. The IDs are now 1, 2, and 3. I'm just sorting these by text, so that's the reason why they're in different orders. And if we let it run through all 3 imports, we would expect it to be right, but it's actually not 100% correct. Because up here, we embedded 3 records, then we added 1 more record, and we ended up with 4. And then we deleted 1 and added 1, and now we ended up with 5 records. Because up here, in version 3, we wanted to delete the thing about Christmas Eve, but it's still here. Because we don't take into account which records are not in the list of data. We're just inserting what is there, but we're not getting rid of anything at any point. And of course, we need to do something about that. So the third way, which I started out doing in the beginning, is the inefficient way. And the inefficient way, if I let it run here, it's very, very simple in that we go in, and when we ingest, we simply go in and delete the data and create it again. So we essentially just emptying out the entire vector store for that specific index and creating it again. Because when we do that, let it run. Get rid of these. Of course, we get the right data. So the first time, 3 records, 3 embeddings, and the 3 records, 4 records, and at the end, we get the 4 records as we want. So you might think this is good. And in our case, with only 4 or 5 records here, we can both handle it cost-wise and time-wise. But essentially, we're just deleting everything and putting it in again. And that can be a problem for many different reasons. First up, it's very inefficient. We are doing embedding services for every single time, despite, in our case, 3 of the records haven't changed at all. We only changed 1 from guest 42 to guest 43 of the Wi-Fi password, but we get rid of the deleted one by being crude. But let's imagine you had 1,000 of these. This actually takes quite a while, and it's a request response to a vector store. So it takes quite a while to do this. And also, every single one of them costs money. And the side effect is, of course, also if we just delete and then insert, while between delete and insert, nobody can use that vector store because it essentially is empty and will not give any data back. So while it works, it can be a problem, of course. That's why whenever I do this, I do a delta. I always do a delta. So let's see how a delta is done, because it's a little more involved, but it have various different properties that makes it much more efficient. So when we run and we go to our first ingestion, we start by getting all existing records, just like we do when we read them out. And of course, since this is a new run, we have 0 records. And then we keep track of what are the active IDs. We are creating our table if need be, and then we're going to go through every one of them. And in this case, we are simulating that we can't have a external ID. We don't have it. Just ignore it here. But we need to set in new grids every single time. But what we can do is we can check the records if any of them matches. And matches meaning all of the vector stored data fields except the key are if they are the same or not. We don't care about the vector because we don't want to check if the vector is the same. They will always be the same if it's based on the same data. And in this case, our vector is based on the question and the answer. But the record might be different because we have an external ID, or we could have a create date or an update date. And in terms of creating an update date can also help be a different approach to figuring out what should actually be updated. If you have directly an update date, you could begin and say only the things that have actually changed since last time. But in our case, we don't have that. We only have the fields. So what we're essentially just doing is we are making a little lookup key, meaning this string represents the data that that are actually here, except the ID and the vector. And for that reason, we can go in and check among all the records, do this specific record here, which is our question about Wi-Fi password, is it already something that is in the vector store with exactly the same data? And in our case, it's not, because it's the first time we run it. We have 0 records. For that reason, we insert it until that ID we have just assigned here is an active ID. Second one will happen exactly the same because we started out from 0 data in the vector store. And at the end, we need to check, are any of the records in the system not an active record, meaning 0 except from 3. Of course, that means none. So there's nothing to delete. But if there were, we could. And we will see that in 1 second. Because now when we go to day 2 in the same system here, we're again going to read all the records. There's 3. And we're going to go to each one of them here and find the match. So the first one here is our Wi-Fi password match, and it already have a match in the database. All the data in the lookup key will be exactly the same because the external ID didn't change, the question didn't change, and the answer didn't change. So for that reason, we just say it's unchanged. We don't need to call the upsert because it will just end up being the same data in the database. Not like a vector will change over time. Second, we go in and check the Christmas Eve one. It is also unchanged. Third one, how to register vacation, it's also unchanged. While the last one, which is our new question in this day 2, about what to do if you're sick, it doesn't find any match because it's a new entry, and it makes it as a new entry here. In this case, there's nothing to delete because all the records are still records that needs to exist, so we don't need to delete anything. And then comes day 3. And if we look at day 3, we change the password, we delete Christmas Eve here, and we add employee handbook. So we go through again, get all the records. In this case, we now have 4. Go to the first one. That is not a match anymore because the question have a different answer. And for that reason, we go in and actually do an upsert. In this case, we are just making a new record. And the reason why it's new is because what we're about to insert here actually have a different ID. Could we have found the ID and reused it? Yes. But I'm just trying to show you this in order to choose. But you could go in from the match record, or we could go in and begin to find it among all these what have the same lookup key and set them. But in many cases, it's not worth doing because it's just extra lookups. Second one is our vacation, haven't changed, so we just go into unchanged. Third one is our unchanged one about what you do if you're sick. And the fourth one is a record about employee handbook. So now we have gone through the 4, but in the database there were 4 already, but one of them have been deleted, meaning the one that was up here. We deleted Christmas Eve, so we didn't ever run that through, and for that reason it will end up in what have been removed. And we see 2 things being removed, and that's because we gave a new ID up here. And what we could have done is, of course, find that instead, but as we didn't in this case, we just get the system and we go in, because we can't really find the record, because how would we among these 3 find the real record, because none of them will fit exactly the lookup key, none of them will fit anything except the external ID, but that will be the next one down here. So we can't really reuse anything if we don't have anything to match it against. And the matching is not fixed. So what we end up doing, and let's see the final output is, in the first one, we called the embedding service 3 times because we insert the first 3 already. In the second one, where we only added 1, we only spent money once. We only called the embedding service once for the new one, which were about if you were sick. The other ones are still just the same, because we don't even touch the vector store. While in the third one, we end up calling 2 times. Once for the Wi-Fi password because we change, and one for the employee handbook because it's new. So there we need to, of course, do real upserts. And what we will see is also that the Wi-Fi password ones ID have changed, because we essentially just deleted the old one and created the new one because we didn't have anything to match it by. So for that reason, we see a different ID, but we still end up with the right ones. And that is, in many cases, if we don't have an ID we can reuse for anything, a perfectly good, valid system, because we're not spending more on embedding services. We are only getting a new ID which didn't give us any value in the past anyway. The last one I want to show is if we actually have an ID that we can use for anything. And it's very simple, because if we just say with reuse here and run it again, there is not really any change. The only change is that since we have an ID, we'd use that as an ID. We use something that is external ID, and it's a good idea to often do the same ID if you can. And by doing that, the vector match will happen, but the IDs will be the same whenever something changes. And for that reason, it will be a real update, a real update. So when we run this to the end, we will again see the same efficiency with our 3, 2, and 1 here. Adding the new one, the fourth one here. And in our delta, where we delete and update, we can see that this one doesn't change IDE because it can do a real upsert. And for that reason, we're not deleting to adding a record and deleting a record. Same efficiency, but now we can reuse. So of course, if you have IDs that doesn't change along the way, it's perfectly fine to do. But no matter what, you need to do the delta scenario, because when we saw with just using IDs, we didn't get rid of the deleted records. So that is actually everything in this. The source code is up on GitHub, and you can just grab it and grab this set of IDs. It's a very common pattern of doing deltas, but something you need to be aware of, and I haven't used in the previous session, so I wanted to make this video. So with that, thank you, and see you in the next one.